The previous class we discussed about uh, different types of distribution. We already discussed, we have started, and we have gone through three different distributions. Can recall those things, that the binomial distribution and Poisson distribution, these two discrete distribution we have discussed, and we have also discussed one continuous distribution which is known as exponential distribution, right? Now the intuition, I have given you time to grasp the idea. When to use which particular distribution, I have not told in the earlier class. I have, of course, I have discussed, but the holistic idea in a nutshell, I have not provided to let you think about all those distributions, because if you go through it and then if you try to speculate, then it becomes more easier. Okay. So, binomial distribution is usually used where you will have two outcomes. Okay. Suppose in quality management, you can see that when we consider the defective items, we use binomial distribution. Okay. In order to calculate the probability of the variable, okay, so we use the binomial distribution because there are two outcomes. It may be defective product, or you may have non-defective product or non-defective item. Now, suppose you are considering the defects. In that case, you cannot use binomial distribution. Why you cannot use binomial distribution? Because you will see that we can measure only the defects. The non-defects we cannot measure. Suppose in a particular month, you can only calculate that how many accidents have occurred or how many accidents have taken place. But you cannot measure how many accidents have not taken place. Okay. So in that way, you cannot measure. That's why in these cases, binomial distribution cannot be used. Okay. Now, another interesting thing is that many times you feel very much confused regarding what to use, which distribution to use. Is it a Poisson distribution or is it exponential distribution? It is very confusing. Let it be very clear. Suppose you are considering the defects. Okay. So whenever defect is nothing but an event. Okay. Now, when you will consider some events within some particular time interval, at that point of or some volume, that per 100 pages you are having, suppose two errors. Okay, the mean error is 2. If you have this kind of thing, if you have this kind of stuffs like per volume or per uh, time, per within some specific time you are having some event, you are considering some event. In that particular case, you use Poisson distribution. But if you have something like you are considering some time within two events, you are considering that time per two phone calls. In that case, you use exponential distribution. Okay, so we have seen that here, what is the probability that time between two calls is less than 5 minutes? So here you are calculating the probability of the time or the volume, okay, between some events. So that's why you are using here the exponential distribution. Okay. Now there is another continuous distribution which is known as Weibull distribution to model time to failure data. So this I am leaving to you, that you will go through these slides and the internet and you will understand the insights of the Weibull distribution. This is, you take it as a home task that you need to go through it and you need to understand the Weibull distribution. Okay. Today we will basically focus on the normal distribution, but uh, to understand normal distribution, first we should discuss central limit theorem. Okay. Now the central limit theorem states that if you have a population with mean mu and standard deviation sigma, that means you are considering mu population and sigma population, and take sufficiently large random samples from the population with replacement, then the distribution of the sample means will be approximately normally distributed. That means from a large population, from a population, you are drawing some large samples, random samples, and you are considering again and again, you are taking the sample means. Now, if you place those means in the graph, it will be looking like a bell-shaped curve, which is known as the normal. It all has to do with the distribution of our population. This theorem allows you to simplify problem in statistics by allowing you to work with a distribution that is approximately normal. The central limit theorem tells us that no matter what the distribution of the population is, the shape of the sampling distribution will approach normality as the sample size increases. Okay. So it is saying that we have already told that when we conduct some survey, like we test some hypothesis or statistical testing, whatever, whenever we do, most of the cases, we deal with inferential statistics. That means we deal with only the samples, but we want to know about the population. We will have to infer about the population. Okay. So that's why in these cases, you can, uh, I mean, so here also you can see that the if you take the sampling, uh, it's not necessarily that the normal distribution, it will be exactly a bell-shaped curve. It's not like that, because whenever you are doing the sampling, you cannot take all the data from the population, But as you increase your sample size, it will tend towards the normal distribution, or it will you know the bell shaped curve will become more accurate type. Okay, here 2 points from the center. The average of our sample means will itself be the population mean. The average of our sample mean will itself be the population mean. The standard deviation of the sample means equals the standard error of the population mean. Standard deviation of the sample means will equals to the standard error of the population mean. Okay, this is you get it from the central limit theorem. Okay, because as you increase your sample size, so here you can see that in a nutshell theorem is provided. The proof of central limit theorem, that is not required. Only you need to know the central limit theorem, that in simple terms it states that irrespective of distribution of population, if you take in random samples and plot the sample mean values, they will be normally distributed. Okay, so even if the population distribution uh, do, it doesn't follow the normal distribution, if we take random samples and plot, if we plot the mean values in a graph, then they will be normally distributed, where mu is equal to mu p and sigma is equal to sigma p divided by root n. N is number of samples, sigma is the standard deviation of the population, mu is mean of the population. So the many, why we are emphasizing on normal distribution, because many continuous variables, they follow normal distribution, and it plays a special role in the statistical tests we are interested in. Okay, so the x-axis represents the values of a particular, the y-axis represents the portion of members of the population that have each value of the variable. Proportion of members of variable that have each value of the variable. It is actually the probability density. It is represented by the y-axis. And the area under the curve represents the probability. It, example, area under the curve between two values on the x-axis represent the probability of an individual having a value in that particular range. So mean and standard deviation tell you the basic features of a distribution. Mean is equal to average value of all members of the group, and standard deviation a measure of how much the values of individual members vary in relation to the mean. Okay, you can see it in the picture. Okay, 68% of the normal distribution lies within one standard deviation of the mean. Okay, 68% of the normal distribution lies within the one standard deviation of the mean. That means 68% of the data will fall up to the one standard deviation from the mean. Okay, so uh, you can see that the definitions are also given, that the normal distribution is a continuous probability distribution wherein most of the values of a data set lie in the middle of the range and the rest taper off symmetrically toward either extremes. The normal distribution is sometimes informally called the bell curve. However, many other distributions are bell curved, and the probability density of the normal distribution is f x mu and sigma square. That means the mean and the variance are given by 1 by root under 2 pi sigma square into e to the power minus x minus mu whole square divided by 2 sigma square, where mu is the mean or expectation of the distribution, sigma is the standard deviation, and sigma square is the variance. Okay, so you can understand that from the normal distribution, you don't need to uh, go through the proof of the formula, you just know it, that will suffice. This is, you have already studied the concept of function in class 12 standard. Like for example, y is a function of x or x square. Okay, you have studied like this. So what does it mean? Y is a dependent variable, whereas x is an independent variable. So for any given value of x, you can find out the value of y. This is the concept of the function. So it is just like the same thing. You can see here in this particular term thing, there is the term of x. So for any given value of x, you can calculate the value of y. If you find out, if you plug in all these values, then you will get y or the fx. Okay, so suppose for this value of x, you will be getting this value of y. For this value of x, you will be getting this value of y. So it's just like that. Okay, now uh, this this particular normal distribution, it is, if we work on this particular normal distribution, it is actually, it is difficult to work with the normal distribution sometimes. That's why we standardized the normal distribution, which is actually known as the Z distribution. Okay, in Z distribution, the mean value we actually treat as 0, and then all the other respective values of particular normal distribution or of it for data set, we can convert it to the corresponding z values. Okay, and if we can convert it in that way, it becomes easier to understand, it becomes easier to interpret, and it becomes easier to take decisions. Okay, how we can do that, I will show you an example in the next slide. But let's first take that how it looks like. So if we want to calculate the z, it is, or if you want to convert the x values, okay, these x values, if you want to convert it the corresponding z values, that means if you want to standardize the data, then x, the formula is x minus mu by sigma. So you need to put the x values, the mu, the mean you need to calculate, then you will be dividing it with the standard deviation value. Okay, and for z note, this is for some, for the special cases you will have, suppose for normal distribution, actually mean is equal to median is equal to mode, and uh, for for special cases mu becomes special cases means for the z distribution, actually mu becomes 0 when you will consider the z distribution. The mu, I have already told that the mean value you need to convert it, you need to treat it as the 0. Okay, and each and every sigma or standard deviation value, the sigma you will be considering as 1. That means the standard deviation you will consider as 1. Okay, so this is the property of the standard normal distribution or z distribution. So now let's take a look at this example. I think the idea will be clear. Suppose you are given a particular data set. Okay, so the normal distribution will look like this. Okay, you can see that the mean value is 1010. Okay, and all the other values are also given. Now when you will standardize this value, so the mean value you will be treating as 0. Okay, and then these are representing the deviations from the mean. This is +1 standard deviation, then 2 the deviations you are actually representing. Okay, and here the z, the formula is also given. Z is the z score or the standard score. You can also say x is the value to be standardized, mu is actually the mean, and sigma is the standard deviation, the data that. Okay, now let's take a look at an example. The idea will be clearer. Suppose a professor is marking a test, and here are the test results out of 60 points. You can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there is a total of 11 students, and their scores are like 20, 15, 26, 32, 18, 28, 35, 22, 17. So you can see that most students didn't even get 30 out of 60. So most will fail. You can see in the data set, only there are 2 students, they have scored greater than 30 marks. So rest of the 9 students, they will fail in the examination. So the test must have been really hard. So the professor decides to standardize all the scores and only fail pupils. Okay. So what the professor has decided? Professor has decided that if somebody gets below the 1 standard deviation, if somebody's score is below 1 standard deviation, only they will fail. Okay, here actually you can see that the problem is one-tailed problem. Why? Because in this case you will be considering only if somebody scores less than the 1 standard deviation. Okay, because if somebody scores more than 1 standard deviation, then he or she cannot fail. He or she can be treated as a good student rather. Okay, but in many cases you will feel, you will see that it is two-tailed. That means if it goes stand, okay, so then you just you take the decision like those values you will not be treating, or you will be, those will be termed as defects. Okay, for example, suppose if you consider that the numbers that are provided in a data set, if this is not number, if these are suppose the diameter of the shaft, okay, so you can have some specific diameter. If it is too large, then you will reject it. If it is too small, then you will also reject it. So that is a kind of two-tailed, but in this case it is one-tailed. So just take a look at the result. The mean is 23. Okay, and the standard deviation is 6.6. Okay, so you put all these values. Suppose you put here x20 minus your mu is equal to 23. Okay, and divided it by standard deviation, which is 6.6. So you will be getting the value of minus 0.45. Similarly, suppose there is 15. So you put here 15 minus 23 divided by sigma, standard deviation 6.6. So you will be getting the score of minus 1.21. So in this way, you can get all the equivalent or the standard scores. Okay, that means the z values you will be getting, and you can see that there is only two students will fail. Okay, because here those who scored 15 and 14, they will fail, because you can understand that the standard z value is minus 1.21. Okay, so it is beyond the one standard deviation, and obviously the below the mean. And here this student is also minus 1.36. Okay, this is beyond the below standard, uh, uh, below the one standard deviation. Okay, now instead of the one-tailed problem, if it is like two-sided problem, two-tailed problem, and if you take suppose the values of, suppose the diameter of the shaft is given, and suppose you have been asked that you reject the values where it is just beyond the one standard deviation limit. It may be less or it may be more. Then what will be your result? Then you can see that you will have this value minus 1.21, minus 1.36. These are below the one standard deviation range, and 1.36 and 1.82, these values are also beyond the one standard deviation range. Okay, so you will also discard these values in case of this. These are the variable is diameter of the shaft, or suppose something which considers that one beyond one standard deviation, you need to reject those values. If it is less, then also; if it is more, then also. Okay, so in those cases, you also need to discard those values. Okay. So now I will discuss about the normality test. Okay, this is important because in many statistical methods like ANOVA and discriminant analysis, linear regression, many statistical analysis, you will see that whether your data is normally distributed or not, that you need to check out. Okay, and there are some normality tests like skewness and kurtosis z values. Okay, should be somewhere in the span of minus 1.96 to plus 1.96. There is the Shapiro-Wilk test where the p value should be above the 0.05. Okay, and the histograms or normal QQ plots and the box plots. Okay, so those things we can also test where uh, you should visually indicate that our data are approximately normally distributed. The box plot is very useful technique. Okay, so now you can see there are some slides are there. Uh, okay, so these slides we will discuss. QQ plot, you can simply you can just avoid the QQ plot, but the mainly the box plot, the skewness and kurtosis values. So and the Shapiro-Wilk test that you can uh, identify. Okay, so the Shapiro-Wilk test, I think uh, so in this particular case, I think we will now discuss about this only the Shapiro-Wilk test. You can search it in the on the in the YouTube. You will get different videos that how to perform the Shapiro-Wilk test, and you can do that using some software like Minitab or STAD graphics. Okay, there's plenty of software out there. And for statistical analysis, Minitab is very good software and very useful software. Okay, so I would like to ask you everyone that if you have or I have also a link. Okay, I can share my Google Drive. You can download the Minitab software and you can install it in your hard drive, because Minitab is very useful software. Stat graphics is also very useful, but Minitab is more useful and widely used by the academicians and by the practitioners. Okay, by using the Minitab software, you can use different types of statistical tests you can perform. So, and apart from the Minitab and Stat Graphics, another very handy software is also there, which is known as SPSS. Okay, that is actually very quite extensively used. Okay, so now you can see that a distribution in which the values equidistant from the mean have equal frequencies is called symmetric distribution. Any departure from symmetry is called skewness. Okay, if you consider a perfect normal distribution just like that, okay, this is you can see that both the sides looks same. Okay, so this is a kind of a symmetrical distribution. Okay, you can see that this is a symmetrical distribution. But in a perfectly symmetrical distribution, mean is equal to median is equal to mode. Okay, if you consider a perfect, the normal distribution, then and it will be symmetrical, and their mean is will be median is equal to mode. Okay, so and you can you also know that what is actually the mean. I have already said what is actually mean. Mean means the mean of the average, the mean value of a particular given data set, and median means the middle value, and mode means the values that are very frequently repeated, those that is known as mode. Okay, and range is the difference between the lowest and the highest value. Okay, so you can see that you can easily understand that in a particular normal distribution which will look symmetrical, that the mean value will be the median value and will be the mode value. That means the average of the values, that will be the middle value, and as well as that will be the most frequent value. We can see here that this is the most frequent. Okay, here actually you get the maximum value of the y. Okay, and the two tails of the distribution are equal in length from the mean. Okay, these values are pulled apart when the distribution departs from symmetry, and consequently one tail becomes longer than the other tail. Okay, so when uh, one particular tail becomes longer, then it is termed as that it is there is some skewness. Okay, so it is you can see that it is said if right tail is longer than the left tail, then the distribution is said to have positive skewness. Okay, you can see here that this is positively skewed because this tail, which is on the right side, that is which is in the right side, that is longer. Okay, so this is called as positively skewed. And which one is negatively skewed? If a left tail is longer than the right tail, then the distribution is said to have negatively skewed. Okay, you can see that here the left tail, it is actually, the it is uh, left tail, it is longer, okay, than the right one. So you can say that this is negatively skewed. Okay, In case of the positively skewed, okay, the you can see that the mean is actually greater than the median. In positively skewed mean value, it is greater than the median or the middle value. Okay, the average value or the mean value will be greater than the median value or the middle value. Okay, but in case of negatively skewed, the median is the greater than the mean value. That means the middle value will be greater than the mean values. Okay, or the average values. Okay. Now let's take a look at this slide. So here we will now discuss that the skewness and kurtosis of z values that we have already discussed here. The skewness, the kurtosis is nothing but the height that we have also covered in the earlier classes. So those values should be minus in the span of minus 1.96 to plus 1.96. The Shapiro Wilk test, you can perform it using for the normality test using the Minitab or Stat Graphics or SPSS. You can perform this test and you should have the p value will be the greater than 0.05. Okay, so that test you can definitely use. And another very good process is to check out you can normally see the histograms. Okay, so that is also very good process. Whenever you get some data, I will always I suggest that whenever you do some survey and you get some data, you plot the data in graph. Okay, yeah, unless if you plot the data, you can have a lot of intuitions about it. You can have some, at least some amount of understanding about the data you may have. Okay, so that's why it is always a better practice that whenever you are doing some survey, or whenever you are dealing with something, for example you are trying to forecast some demands, it is always a good practice that you get, after getting those data, so you plot those data. Plotting those data is very important. Now to know, in order to test the normality, there is also a very good thing that is called a good test, that is called the box plot. Okay, so in order to we need to know certain terms. So that's why this slide has been given. So here we will first we will know the term what is quantile. Okay. In general, quantiles are just the lines that divide data into equally sized groups. That's the technical definition. And so that is known as quantile. So suppose you have got some data. Now if you divide the data into some equally groups, so each and every group will be termed as the quantile. That is the technical definition of the quantile. Now you have also heard about the term called percentile. So what is percentile? Percentile is also nothing but a quantile. Okay. Technically speaking, percentiles are just quantiles that divide the data into 100 equally sized groups. So if you have got some data and if you divide the data into 100 equally sized group, then each and every group will be termed as the percentile. Okay. So now what is quartile? Quartile means, suppose three quartiles, Q1, Q2, Q3. So suppose you have got some data and if you divide that data into three equal divisions, then that will be treated as the quartile. Okay. So uh, sorry, if you divide it into equal four divisions, then you will be dealing with quartile. Okay, you will be getting some points like for example, suppose you have got this data. 5, 6, 12, 13, 15, 18, 22, 50. Okay, you have got this data 1, 2, 3, 4, 5, 6, 7, 8. There are 8 in a particular data set. There are 8 numbers. Okay, so you can easily understand that there you are dividing this particular the whole set of data into 4 equal divisions, and you will be having 3 quartiles, Q1, Q2, and Q3. These middle points will be treated as the quartiles. Okay, so just here, there is also the same thing. Okay, suppose 3, 4, 4, 5, 6, 8, 8. 1, 2, 3, 4, 5, 6, 7. There are 7 number of data. So you can see that Q, you have divided it into equal 4 divisions, and Q1 is 4, equal to 4. It is termed as lower quartile. Q2 is known as middle quartile, which is also termed as the median or the middle value of the entire data. And Q3 is okay. Q3 is known as the upper quartile. Okay. So in this way, I think the the understanding of regarding the quartiles, that idea is clear now. Okay. So now there one particular problem is given, that how to draw, okay, how to draw the box plot. One particular problem is given. So this particular problem this particular problem we will discuss in the next class. Okay, in the next class we will discuss, tomorrow we will discuss this particular thing. Okay, and also we will focus on the chi-square distribution and F, chi-square distribution and F distribution, because F distribution is very common and it is used very often. We deal with ANOVA, analysis of variance, and in that particular time the F test is done. Okay, and we will also find out the maximum likelihood estimation, how to deal with the maximum likelihood estimation, how to or why the maximum likelihood estimation is required, these things. Okay, so now I am going to stop the recording.